Here's lesson 11.2. I will probably put out all 3 lessons pretty quickly this week. Some of you want to get them done right away. Others it takes a little longer, so I'll let you work at your own pacing a little bit. The due dates are still necessary so that I don't get behind in grading, so please have your assignments done by the time that I said they're due. But if you want to get them done early, that's totally fine by me. 11.2 is about percents. I think this should be pretty easy for you. You've done quite a bit of this. You did some of it probably in grade school. And it doesn't really take it to the next level. So 11.2. I have my own method. I wrote Mrs. Stofflet's method on the notes. I don't know where or how I picked it up, but it's what completely makes sense to me. You can also solve percents by using proportions, which I explained proportions in lesson 1. I can go over that again in here if you'd like. It's certainly fine if you show your work using proportions, but my method is this. So when you read a question about percent, or really this is my real world method as well, something like example 1, which says what is 150% of 200? So you need to find 150% of 200. Or 26 is 40% of something else, and you need to find what that other number is. Excuse me. Any problems with percent I solve in this way. So the word what, or what number, or what percent, basically whatever it is you're trying to find, that's your variable. You don't know what it is, so you use a letter. That's the purpose of a variable. Change the word of to times, or to a multiplication symbol. If I said 3/4 of 100, you could do 0.75 times 100, 75% of 100. The word of in a question for mathematical purposes is the same as multiplication. Change the word of to a multiplication symbol. Change the word is to an equal sign. Well, that makes sense, right? It's kind of like 3 plus 4 is 7. Is the equal sign. I'm going to write this kind of multiplication sign, but don't use it, right? That's, but so multiply. You could use parentheses maybe. There you go. Change all percents, though, to their decimal equivalents. So when you see a percent, so if it's 150%, you have to change it to 1.5. If it's 34%, I'll write, for example, 34% is going to be 0.34. Or just so you know too, something like 5%, right? You're moving the decimal 2 places, so it's 0.05. Be careful on those. But change the percents to their decimal equivalents. Okay, so I'm basically going to write a math problem out of example 1 and example 2. What x is equal sign 150%, change it to its decimal form, so 1.5 of, the word of means multiply, so I'm going to multiply by 200. This is how I find 150% of 200. Show a little work on these, please. Show that you know how to change the question to a math problem. Okay, I know some of you can find 150% in your head, so can I. I'm not as concerned about, hey, I can get the answer, to can you use this format, I guess. So I think you know that 1.5 200s, or if you multiply this, you're going to get 300. X equals 300. Okay, so if I wanted to, you also could set this up as a proportion. Percent means out of 100. So another way to do this problem, if I chose to, would be what is 150%? So you're going to say something like 150, that's 150%, like out of 100 is, and then you would say like what out of 200. So to solve the proportion, if you use cross multiplication, is 150 times 200 and divide by 100. That's one way to look at it. If you think about scale factor, 100 times 2 is 200. So 150 times 2 would be 300. So like scale factor. Okay, so I want some type of work of either, hey, I can solve this using a proportion, or yes, I can solve this using the Mrs. Southwick's method by writing an equation out of it and solving it. Okay, one of those two examples. I'm going to continue today's lesson using this. If you love your proportions and percent out of 100, don't forget that you need the 100 in your proportion. Okay, example 2. 26. So if I write a math problem out of this, and I just read this left to right, 26. The word is an equal sign. 40%. All your percents need to be in their decimal format. So 40%. The word of is going to mean multiply. And what number is your variable? So there is your math problem, and you need to solve for x. So isolate the variable, get the x by itself. You're going to divide by 0.4. And if you take 26 and divide it by 0.4, you should get 65. When you're done, when you get your solution, will you go back and read your question to yourself again to see if your solution makes sense? Sometimes I continue to get answers and I speak out loud and say, how does that even make any sense? So look up here. 26 is 40% of what? Does it make sense that 26 would be 40%, a little less than half of 65? It does. Or also, mathematically speaking, when you take a number and you divide it by a decimal, smaller than 1, your answer is going to be larger than that number. Okay, so think, have some thoughts mathematically on whether or not your answer that you're getting makes sense to the question. All right, example 3. 48 is what percent of 160? 48 is what percent this time, okay? So the question, your variable is actually going to be a percent. The question is what percent. Of means multiply. We're multiplying by 160. There's your math problem. You'll divide by 160. Noticing if you take 48 and divide by 160, you should get a decimal. So x equals, and I get 0.3. The question though was what percent. So really just like when I had a percent and I changed it to decimal form, if I'm getting a decimal form of an answer and my question is what percent, I need to say what percent this is. So this is going to be 30%. Don't forget to convert that back to its percentage form. Okay, so don't write 0.3% is my, I guess, point that I'm trying to make. 48 is 30%, a little less than a third of 160. It's not 0.3%, less than 1%. Okay, so 30%. Example 4, 240 is what percent again? So x of 150. Think about your problem before you start it. You could estimate an answer before you start this. 240 being a percentage of 150, you better get more than 100% because 240 is larger than 150. So your answer is going to be turning out to be greater than 100%. If I divide by 150 on both sides, x turns out to be 1.6. Again, converting that to this asked for a percent, so this would be 160%. Moving your decimal 2 places to the right. Okay, so write a math problem. The solving for x part, you are all over this. You're all pros at that. Get your answer. If the question, however, if your variable is a percent, make sure you're changing your decimal back to a percent by moving the decimal 2 places to the right. If you solve this using a proportion, you will not need to do that. Okay, continuing on. This is a rather short lesson. You'll like that today. Alrighty. Word problems. You read in a magazine that an affordable rent is one that is no more than 30% of your salary. All right, so 30% of what you make. The apartment you want to rent is $625 a month. It's interesting to me that these notes are really, really old, and really that amount of rent right now is still a pretty decent rent. At least, what must your monthly salary be for you to be able to afford this apartment? Okay, so basically you want your $625 rent to be 30% of your salary. And what's missing? What don't you know? What are they asking you to find? The question is, what must your salary be? Okay, what do you need to get paid every month in order for that to be an affordable rent? I'm going to write this out as a sentence, I guess. So $625. Sorry. $625 is 30% of your monthly salary. So 625 is equals 30% as a decimal, and your monthly salary, which is question mark, right? Which you don't know. Divide by 0.3 on both sides. And you should get $2,083.33. I think I rounded that. Equals X. Or is your monthly salary. So if that's how much money you bring home, you can afford the $625 rent. Okay, example 6. The graph shows the results of a poll of students taken to find out the average amount of time spent on various activities in a 24-hour period. So a day, I guess. If you spend 1.5 hours, or if you spent 1.5 hours on homework yesterday, was this percent of time about the same as the poll average? So this says how 24 hours are spent. We are talking about homework. So the poll says that most people spent 7.9% of their day on homework. So we're wondering, is 1.5 hours in a day, 24 hours, 1.5 out of 24 hours, close to representing what this 7.9% is? All right, so I want to know what percent is 1.5 out of, sorry, 24 hours. Okay, so really, like when I pass back a quiz or pass back a homework assignment, let's say a homework assignment, and you get 6 right out of 8, and I write 6 over 8, and you do 6 divided by 8 to figure out your percent. That's the same here. If I want to know 1.5 out of 24 is what percent? Okay, so this is out of, not of. Out of, like a total. This is a part. This is a whole. Out of would mean divide. Okay, so 1.5 divided by 24 equals 0.0625. Change it to a percent. If I move the decimal 2 places to the right, 6.25%. Okay, so if you spent 1.5 hours, out of 24, it's about 6.25% of your day. We're supposed to be seeing if that matches the poll, and according to the poll, it's 7.9. We spent 6.25. Your answer is however you're viewing the comparison with those numbers. So this is close to 8%. Your answer could say no, because I spent, or this person spent 6.25%, so it's lower. Or you actually could say, you know, it's depending on, do you think that that's close? You could say yes, 6.25% is close to 7.9. It's really not that far off when you look at, you know, it's not 31.6%. So close but less. Might be your answer. The question was this percent of time about the same as the poll average, and explain. Yes, it's close but less. Might be my answer. Okay, example 7, last example. You're going to get a few of these coming up. Kind of like them. Let's see what you think. You can respond to me. Oh, I like those too. Or, oh, Mrs. Stofflet, those are brain pop. All right. I like the emoji with the for your brain. What percent of the region is shaded? What percent of the region is not shaded? These are all rectangles and squares. So I think you know how to find area of rectangle and area of squares. Just length times width. Can you find the area of the whole? Area of that entire rectangle. What's the width? 5 and 5. The width is 10. What's the length? 5 plus 7 plus 5 is 17. Length times width. It's 17 times 10, or 170 is the whole area. Okay, so I think it's a little easier to do the part that's not shaded first. So I'm going to start by not shaded, which is my 2 blue squares. The area of this blue square, 5 times 5, is 25. The area of this blue square, 5 times 5, is 25. My unshaded part, these two together then, would be 50. So, not shaded. I'll write this over here. Not shaded. 50. What did I say out of was? Out of is division, right? So 50 out of 170. Okay. So 50 divided by 170 gets me 0.294, about. It doesn't say where to round to or anything, so change to percent. 29.4%. I'm going to say about. Unshaded. Okay, you don't have to do an entire new math problem to do the shaded part then. Your whole is 100%. So the rest, the shaded part, if you took 100% and subtracted 29.4%, the rest should be shaded. So 100 minus 29.4 should give you 70.6. is shaded. All right, you should be able to go ahead now then, this being 11.2, and do page 653. I wrote 13 to 39 all. I can post the answers to the evens. I just think you need to practice as much as you can. So 13 to 39 all and number 45. Don't forget about number 45. And also this is due tomorrow, so get this done as soon as you can today. I will probably post 11.3 and possibly even 11.4 videos today so that those of you that want to work ahead can. This week's not too bad, but buckle up, because next week's we're going to be using polynomials with fraction rules and multiplying and adding fractions with polynomials. So here we go.